Hey, what's up? It's Jake from Nimbus DevOps, and I'm here today to talk to you about mapping types, specifically dictionaries. So, of all the built-in Python data types, a dictionary is definitely, I think, the most interesting or powerful. It's the only standard mapping type, and it's the backbone of every single Python object. So, a dictionary maps keys to values. And a key needs to be a hashable object, while the value can be really anything. Dictionaries are also mutable, and there are quite a few different ways to create a dictionary. So let me give you a couple examples. So let's say I have a variable a, and I'm going to make a dictionary with dict dict, and I'm going to say a equals 1 and z equals -1. So that would be creating a dictionary. I could also create dictionary b as a set like this, and that would be 1, the key a to the value 1, and also the key z to the value of -1. Add some spaces here, make it a little easier to read. So that would be another way to do it. I could make a dictionary C, use the dict zip, which is an interesting construct I will get into, and say we have a list A and a list Z, and with keys 1 and -1 respectively, and close that like that, and I could create a dictionary like that. I could also create dictionary D and say dict with a list object A, key value 1, and Z value -1, close, 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 and you could do it like that. You could also, lastly, do E dictionary, and we'll do a object set of a key to a value and another key to a value. Close the set, close the object. And if you did A equals B equals C equals D equals E, you would see that it's true. You may have seen me use these double equal signs before. This just means that they're equivalent, that the values are exactly the same. So whereas a single equal sign is an assignment operator, essentially assigning a value to an object, like A equals dictionary, A equals 1, Z equals -1, whereas the equals sign is saying, hey, I'm saying that this is exactly the same as this. So this statement here is just A is exactly the same as B is exactly the same as C and D and E and so on. And then it comes back as true and evaluates the true. So we know that these are in fact all the exact same way of basically creating the same thing. So um, there's another way to compare objects, which involves the is operator, which we have not used. It checks whether two objects are the same, like A is B. I could show that here. A is B, and that says false. And so you have to be very careful when using comparative operators. Um, but the reason this is false is because it's actually checking the ID, the object ID. And while all the values of these dictionaries are in fact identical, the object IDs are unique. And if we take the ID of A, and return that here, and the ID of B, we can see those are the same. And so saying ID of A equals ID of B returns false is the same thing as saying A is B. So that's the difference between equals and is. So it's good to know what exactly you're comparing, whether it's the value of the object, as a property, or if you're comparing the object properties identity. So those are two different separate things. Um, so the other thing we used here that's kind of interesting is zip. So I want to talk about that. It's named like after the real, just like zipping something, which takes two things together, just like a jacket zipper or a purse zipper or something like that. I'm taking one element from each part, and you'll notice that zippers have teeth, right? And so they take this side of the zipper and this side, and they join them, and slowly the tooth from each side slowly joins together until you have a sequence of teeth that are all joined together. So that's essentially what zipping is, in the physical world sense. And we're kind of doing the same thing, right? We're going to take one element from one list or one dictionary, and we're going to put them together with another list from something else. So you'll see here when I said make a dictionary, and I want you to zip A and Z. So imagine A and Z are two teeth on this zipper, and I have one and negative one over here. And when we zip them, we're just putting them together like this, like you would be zipping up a zipper. So we're going to zip these up to A and 1, Z and negative 1, and then make a dictionary out of it. So that's essentially what this zip thing does. And I'll give you another example of this here. Let me clear this so you can see. Okay, so I want to make a list. Okay, so I'm going to make a list, and I'm going to zip together, now that you know how this works, H, E, L, L, O. Okay, so what do you think? What do you think that does? It doesn't really do anything. That's one list, right? So I'm going to make a list, but I'm going to zip together two lists into one list. So my first list is hello, Hello, and then my second list is going to be 1, 2, 3, 4, 5. Okay, so I'm saying, hey, the left side of my zipper, it could be whatever side, is hello, and then left side, and then the right side is 1, 2, 3, 4, 5, and I'm going to zip these together, and what I should see is H1, E2, L3, L4, O5 is what we want to see. So if I hit enter, we can see that we get exactly that. We have a list of tuples where the tuple has a string and an integer indexed at 0 of each respectively. Like, well, in this tuple is 0 and 1, 0 and 1, 0, 1, 0, 1, 0, 1, so on and so forth. And we zipped them together. So that's one way that you can zip two lists into a single list where each element of that list is a tuple with the values indexed identically in each list. So index in hello, index 0 is H, and 1, 2, 3, 4, 5, index 0 is 1. Both index zeros are made into a tuple, which is made into element at index 1 of my new list. Kind of complicated, but hopefully that makes sense. Here's another example. Let's see. So let's list. We're going to make a list, and I want to zip something else. But this time, let's just zip the whole word, hello. But I'm going to use this little function called range. And I'm going to go range 1 to 6. Let's close all these. And what does this do? Oh, wait, I messed up. List zip hello range 1 to 6. Because I spelled list wrong. Hi, how's it going? And that accomplishes the same thing. So this is a great time to talk about something being more Pythonic. So this is a more Pythonic way of accomplishing this. And that's because this is explicit, because I'm explicitly assigning each index in this list and each index in this list and then zipping them together. Whereas here, the more Pythonic way would be to say, hey, zip the whole word hello, but I want to do it in the range 1 through 6, which, uh, you know, with a range function, the last numbers, it's not including that, but the first number is including. So basically, this is 1 through 5. So doing it this way is much shorter. It may be a little bit more complicated to understand at first, but it looks a lot cleaner than this, because this, imagine if you had a really long word, right? This would become, or if you're dealing with 1,000 numbers or 10,000 numbers. I would rather type range 1, comma 10,000 than range then make a list with every single number 1 through 10,000. So this is a much more Pythonic, elegant solution. Yeah, so the reason that zip returns an iterator and not a list, so if we want to see the result, we need to exhaust the iterator into something. So in this case, we do that with a list. So that's kind of what we're doing with zip, because yeah, it's just easier. Let's see. So let's take a look at we're talking about the real zipper example. Let's go back to dictionary and see what we can do as far as manipulating it. So how do we manipulate a dictionary? Let's see here. This is the CRUD type of situation. All right, so I'm going to create some open and close curly braces, which creates a dictionary, right? It looks like a set, right? Kind of, but a set is saved with those, but it requires calling the set function. So we're going to make a dictionary, and well, we made an empty one, and now we're going to say d a equals 1. Okay, and then we're going to do db and 2. Okay, this is unordered, right? So now if I take the length of d, the length of d, we can see that it's 2 long. Okay, well, what does that mean? So if I do dA and return that, I get 1. And if I do B, I get 2. So it has 2 values, right? But if I do D, I can see it shows this dictionary object. Remember, everything's an object. This is a dictionary object. So the braces really help illustrate that this is one object. And in that object, we have a key value pair A1 and a key value pair B2. Okay. You can also, so that would be how you read it, right? The R in CRUD. So let's talk about, when we did the A, right? So, or the create. So let's do a delete. So let's do delete D A. Del is delete. And now if I return D, I get one object with one key value pair B2. Okay, so let's add something else. So let's add a C, and we'll say this is 3. So now I have a B and a C. Okay, but you can also do some membership checks. So I could say C in D. Yes, there is a C in D. That's true. Do we have an E in D? Well, no, we don't, so that should be false. You can also just do D clear, right? And then if I return D, it is an empty dictionary. So it's pretty easy to access keys in a dictionary, but no matter what the type of operation you're doing, it's done using square brackets. So that object is a square bracket. You'll see that I use that for A and B and C and all that stuff. So if you remember from strings, lists, and tuples, you probably were accessing elements at the same position through square brackets as well, which is another example of the consistency in knowing that if you're trying to iterate or index through something, some object, that doing that with square brackets is it works. No matter the type you're using, it works exactly the same. So now we'll go look at 3 different special objects in a dictionary. 2 of them I've already been talking about, and the 3 are keys, values, and items. Okay, so we can dynamically look at the dictionary entries and how they change. The keys return all of the keys in the dictionary, and there's literally a keys function. There's a values function, right? And there's also an items function. So the keys return all the keys, values return all the values. The items returns all the keys and values in the dictionary. So let's take a look at this a little closer. And we're going to make a dictionary D. Dict equals zip. And let's do hello range 5 and call D. And I have H0, E1, L3, and I L or 0, 4. Interesting, right? So if I do D dot keys, I can see here are my keys. Okay. If I do D dot values, I can see here are my values. If I do D dot items, here are all of my items. Pretty easy. You can do membership checks like 3 in D dot values, and that's true. And I could even do something like O4 specifically in D dot items, because an item has both a key and a value, and that is true because you can see it's right here. So you notice he created a dictionary over iterating over the zipped version of the string hello, right? And that list came 0, 1, 2, 3, 4. The string hello has 2 L characters, and you're probably wondering, well, why did it create one with 1 L? And the string hello has 2 L characters that are paired up with the values 2 and 3 by the zip function, which is also kind of explaining why we have a 0, 1, 3, 4 dictionary value. Okay. So that's why that happened, and that's because of the zip function. But the second occurrence of the L key, the one with the value 3, right, overwrites the first one. So when you notice when you're asking like for any view, the original order in which they were added is preserved, and so it's just something that you might want to take note of. The dictionary type has been re-implemented to have a more compact representation, which resulted in dictionaries using much less memory. So that's really good. But there have been some changes, and these changes, and it's good to keep up with all the PEPs, right? The like PEP 8, PEP 20. You've heard me talk about those before, just to see what kind of stuff comes out. But the official Python documentation, it's worth reading if you get into this. Because there are some cool features too, like making dictionaries reversible and going the other direction. So let's take a look at some fundamental tools when we talk about iterating over these, what we'll call collections. Okay. So I have I have this dictionary, right? So what if I want to pop an item? Do you remember using pop? So if I pop an item, it's going to grab that last item, right? And if I do D, I can see it popped it right off the end. Now, where did this name come from? I actually don't know, but it is what it is. And if I did a D pop L, I don't need to pop the item. I'm just popping L, and it pulls up the value 3. And if I return D, now I only have two things. If something's not a key, this is kind of a weird. You can remove a key in a dictionary with D pop, and then I could just be like, not a key. Boop. What is that? Right? So, if you're going to remove a key in a dictionary, you're going to get a key error if it's like, I don't know what that is, right? But if I said not a key, comma, and then default dash value, something like that, you get this return default value. So it has a default value, I guess. And you'll see it doesn't really change anything. But if you pop something and it's not there, you'll get an error. If you pop something that's not there and you have a default value, it will return the default value but not change anything. Let's see, there's an update. So for our CRUD functionality, you can do D update, and I could say, here's another value. Yeah, let's do another value, something like that. And return D. You can see there's all values, another value. And since I made an error, we could actually update another value to values and return D and see now I spelled it correctly. Let's see, you can return things. So if we want to read, you could do d.get and then just to give me A. And we could see In this case, there's nothing. Let me see here. But if I made an A, I could do d.update, and let's make an A, and let's give it a value of 13. 13. And I do D. There, I have an A. Now I'm going to get A, and now it returns something. So you can get values as well if you don't know whether there's something there. So there's all kinds of different things you could do. If you said D get A, where the default value, if the key is missing, is 177 and it's not there, it'll still return 13. If you were to do this with B, because B doesn't exist, right? It's going to return 117. So this is kind of like, hey, go get B. And if you don't find anything, just use 177. You know, I get this request when I go to the store for my wife, where it's like, hey, I need you to get this thing from the store. Go get Dave's Killer Bread Thin Slice. But if they don't have it, then just get the regular sliced one. So it's kind of like that. It's like my wife asking me for bread at the store. That's exactly what it's like. So these are all fairly easy to understand, I think. But there is another thing we want to talk about probably real quick. It's none. The word none. Okay. Every function in Python returns none unless a return statement is explicitly used to return something else. Like at the store, if my wife tells me to go get bread and doesn't tell me that if they don't have it, then return with this other type of bread, I'm just going to go there and see they don't have it, and I'm not going to buy anything. And Python does the same thing. None's frequently used to represent the absence of a value, so it doesn't mean zero. It's quite commonly used like as a default value in arguments where there's a function definition or declaration and there's just like nothing. So you would just say, hey, this doesn't even exist. False and none both evaluate to false, by the way, for Boolean stuff, which might seem weird, but it's true. So for Boolean, there's really no difference between them. But actually, you could argue that that's not true because there's an important difference, meaning that false means you actually have information and the information you have is false, whereas none means that there's no information. And no information is very different than incorrect information, right? So I guess think about it, if you went to a mechanic, right, and you said, and you're getting your car, your oil changed, and there was both an option of saying false and none, and their version of that was, hey, is my car ready, right? And then the mechanic said, no, it's not. That would be false. If he said, I have no idea, that would be none. But those are two different things, right? Because one, you're like, oh, okay, when's it going to be ready? But then the other one might be like, well, can you go ask somebody that does? Like, so depending on what you're trying to accomplish in your code, they're two entirely different things, and you want to make sure you're using the correct one. But false and none both evaluate false in the Boolean sense, but that does not mean that they are the same. So one last method we'll talk about is the set default method. Let me clear this out so you can kind of see a little bit. So I'm going to create an empty dictionary. Oops. First, I'm going to get an interactive shell, and then I'm going to create an empty dictionary. And I'm going to say d.setDefault. Okay, d.setDefault. And I'm going to set default A and 1. So A is missing, so we're going to get a default value of 1. But if I type D, I can see there's a A1, which is also the key value pair that's been added, right? So you can try to override that value and try to set it to 5, but it's going to return 1. So you can't override because that's the default value. So that's pretty much it for dictionaries. If you want to kind of test your dictionary ability, try to guess what'll happen here. Try to guess what'll happen here. So I'm going to make an empty dictionary D, right? So there's nothing in here. And I'm going to say d.setDefault, and we'll do a default A open dictionary. dot set default of B and an empty list dot append 1. So what does that do? We have a d.setDefault. Okay, so it's going to set the default value of A as a key and the value as an empty dictionary or set, right? This kind of object. In that namespace, though, it's going to set the default to B as an empty list inside of there and then append 1 to this entire thing, to this namespace. So this namespace 1 should belong to B, where B1 is here. So you might think it would say A is the first key and the value is B, comma 1. So what do you think will happen? What do you think will happen? I don't know. Well, let's double check and see. If I say D is which you know is a default value, and that is set to A, big A, and little b is set to big B, like this. Okay, that'll be D. And then I've got this E value of B, and we'll do the number 8. And C will be a big C. Why not? And then let's do a union, DE. Okay. Interesting. So what happened there? There's some default stuff going on, right? Notice there's a difference between B, little b, big B, and little b and 8. And it used little b8. So think about why might that happen. If I union E to D, we get B, big B, C, C, A, right? Remember about iteration, how iteration works and how the values work, and that if you have duplicate values, the second value is always going to override the first value. So keep that in mind. What do you think this does? D and E. Well, it doesn't do anything. What do you think it does if I use the correct brackets? I'm like, that should have done something. There we go. AA, B8, CC. What does that do? What does that do? So there's a couple things you can do with this, and you just have to know, like, when you start getting into these more complicated nested type things, that the behavior you want it to take, you're creating rules, right? Well, this should be this way. Unless this happens, then do this. Unless that happens, and then do this. And you can code these things like this, very short, very easily, and be able to throw all kinds of stuff in there. And Python will always be able to evaluate exactly what the answer should be. So anyways, just know that the D and E dictionaries in this one have B in common, right? So that with the dictionary object B, the value associated with B is B, whereas in E it's 8, right? So that means that when you merge them, E on the right-hand side of the union operator, the value E overrides the one in D because of the iteration sequence, right? The opposite happens, of course, if you go in the other direction, which we saw. And you can also see how unions can be performed using this little double star operator, which is an interesting way of doing that. So you might not be like, I don't know what this is, but I see that there's a union. And this method of using the double asterisk operator is how you would unpack a dictionary. And dictionary unpacking is another term that you may hear. A union can also be performed as like an augmented assignment operator. So you could do like D union equals E, and it's like a way of assigning something with a union. There are PEPs on this. It's a PEP 584 on this feature. If you're really interested in how all of this works. But that's pretty much it. So these are the built-in data types for dictionaries. And if you have any questions, let me know. But if not, I'm going to get into some time date data types. So have fun.